Hello, everyone, and welcome to today's session, Reducing Emissions and Maintaining Performance with HVO Fuel. My name is Pamela Larg. I'm going to be your moderator for today's discussion. And today we are streaming via GoToWebinar, and we would definitely love to hear your questions throughout the session. So if you can send your questions via the Ask Staff a Question box on the right-hand side of your screen, we will attempt to answer all of your questions throughout the session. However, if we don't get to yours, we will follow up after the session has concluded. If I can also start by confirming the agenda for today's discussion. Our first presentation is going to be looking at business insights and the HVO market. We will also be discussing the chemical view on HVO, as well as fossil fuel and FAME. We will look at HVO fuel testing and validation, as well as NEST My Renewable Diesel, HVO. Once the presentations are concluded, we will have a Q&A session with all of the panelists, and that's when we hope to get to all of your questions. So please feel free to share those starting from now. The sooner you get your questions to us, the sooner we can address them in the discussion. If I can now announce who will be speaking on our panel today, and we have Michael Stupa, Vice President, Stationary Business Development, Strategy and Product Management from Rolls-Royce. Also joining us from the Rolls-Royce team, we have Anna Keller, Product Owner, Stationary Sustainable Engine. We have Anya Keller, Senior Expert, Chemistry Lab Fuels from Rolls-Royce. And finally, Robert Welts, Senior Manager, Power Generation Engine Support from Rolls-Royce. From the NEST team, last but not least, we have Mats Hultman, who's Head of OEM Partnership within Innovation and R&D. So excellent to have all of our panelists with us today. I'm sure we're going to have a really engaging and interesting discussion on what is an absolutely trending topic at the moment. So welcome to our panelists, welcome to our listeners, and without any further ado, I'm going to introduce our first two speakers. Michael has broad global experience from finance and controlling to transformation and strategy within the energy sector. He's going to be joined by Anna, who has 10 years experience in project and transformation management. So I'm going to hand over to you, Michael and Anna, and yes, the floor is yours.
Thank you very much, Pamela, and also a warm welcome from my side. What is the session for all about today? What we are realizing is that decarbonization is of increasing importance. I mean, something like 10 to 15 years ago, that was rather a report which was produced by corporate communications and then published, but the public awareness out of the report was rather limited. That has changed significantly in the last 10 to 15 years. Sustainability is now on the top of the agenda, not only on the CEOs to really contribute also towards and mitigating the climate change impact, but also even nowadays on the CFO agenda, because a lot of corporate finance bonds are already covered and interlinked to contributing towards net zero. And we as Rolls-Royce are also taking the responsibility seriously. What you can see on the left-hand side is that we set ourselves the ambition to reduce our product portfolio footprint, meaning which kind of CO2 emissions the product we are producing and releasing to the market are emitting over their lifetime. And we want to reduce it by 35% in 2030 and to become net zero with our product portfolio in 2050. In order to do so, we see two big levers. The one is new technology. So really developing new technology, which is completely CO2 free, like for instance, fuel cells, which can be used by using green hydrogen. But the other even more important topic on the short run are the conversion of our existing internal combustion engine portfolio towards sustainable fuels, because we see that this is one of the biggest levers in order to contribute towards net zero even today, and not necessarily waiting for new technology. When looking on the focus for today's session, we would like to emphasize the opportunities for our diesel portfolio next to the already mentioned new technologies we are developing in parallel. If you want to find out about that one, please always feel free to visit our homepage to see the latest and greatest development in that area. When now looking on the diesel side, we are really proud that we released the two main engine series in the power generation field in April 2022 for the release of so-called fuels according to the directive of EN 5940. On that one, it's really also important to mention EN 5940 is covering a broad amount of different fuel types, also including, for instance, fuel types like gas to liquid, but also coal to liquid. Today, we would like to emphasize and give you more insights about the specific fuel type HVO, which is also part of 5940, because we can see that these benefits, it's a proven technology, it's available already today, and it comes with a significant CO2 footprint decrease. So therefore, it's all about HVO today. We will also focus on power generation, but next to that one, we are also releasing almost on a quarterly basis additional applications of our portfolio towards this exciting fuel type. And that's why really happy to have a strong team also here in the call today, providing you further insights. And by that one, handing over to Anna, who can give us a little bit more insights about how does the market.
Thank you, Michael. So I would move on. It's always a question about the availability and how are the production volumes developing. So then I move to the next slide. There it is. Great. So now you have an overview of the global HVO processing and co-processing volumes. It's a comparison between 2020 and an estimation on 2025. On the right-hand side, you can see that the volumes will be more than quadrupled until 2025, especially in North America, where you have 9 times fold growth, and followed by Europe with a 2 times growth, and especially also in APAC, we assume a growth of about also 2 times fold. This is driven by more than 20 companies who have announced investment in HVO factories. And one interesting side fact is that HVO also allows actors to have feeds in aviation fuel, bio-naphtha, bio-LPG, which are co-products of the HVO production. So a broad span with the feeds into the market. Most popular countries are pushing alternatives to FAME, especially because it's also based on similar feedstocks, which will Anja Keller have a deep dive into it. And yeah, HVO is currently the only commercialized option for FAME. So therefore, you can see that this is a commercialized approach to decarbonize your portfolio already today. I will give you an insight into the pricing mechanism and also into the emission regulation. So this is more or less focused on Europe. So within Europe, you have 4 pricing mechanisms, which consist of into the energy content of the product. So it seems it's like a diesel equivalent. So the same energy content, so the same pricing. And then you have a premium on it, which consists of the 3 following points. So the physical properties, e.g. FAME content within the EN 5940 norm. It can be also considered up to 70% FAME content. Then on the third point, you have an insight into the emission regulations, so that HVO needs to correspond to the Fuel Quality Directive of the European Parliament and Council regarding the composition of diesel fuels. And additionally, you have the Renewable Energy Directive, so RED II in Europe, which is promoting the use of renewable energies. And the Renewable Energy Directive, in this case for the pricing, defines the energy content and GHG values. And the fourth point is the HVO alternatives in the market, so e.g. other EN 5940 fuels like GTL or something, and sum up these 4 pillars, you gain a pricing. And in the next step, you can see the HVO deployment exemplary is fully referring to the power generation market. Because so there it's based on the RED 2 that each member state has to fulfill obligated targets in the sustainability, and individually they are also able to define more challenging targets, and from these reveal the mandated markets, which is very heterogeneous in Europe. And this is defined that certain applications are obligated to fulfill GHG reductions, and you can charge it on the HVO price that it's competitive to a diesel price. This is fully our market assessment, so our view on the power gen market for the fuel to substitute diesel with HVO. It consists of an assessment between interviews with Neste, with channel partners, with customers, and our third parties and our subsidiaries with boots on the ground in Europe. Within the sustainability, this is our overall impression of national measurements to reduce greenhouse gases. The local availability is a distribution network which consists of distributors, public fueling station, bulk deliveries. Then we consider the legal release. So is HVO or EN 5940 fuels permitted by law? Is it a mandated market? So is it considered within a greenhouse gas reduction program? And the fossil fuel taxation is just, is there a substitute, so an energy tax reduced substitute in the market which can be used by power generation? So something like red diesel. And if you are able to red diesel, you have currently no tax subsidized product or tax reduced product in the market, like from an HVO perspective. So the price gap is getting bigger. And from this, we derived a general HVO market attractivity to say, okay, for instance, in France, so the preconditions are perfect to use HVO from our point of view in the off-highway market, so power generation. And in Germany, it's a median attractivity because it's currently not fully considered by the government. There need to strongly discussions between the government or the national regulations and interested parties. But Neste and Rolls-Royce are strongly believing that collaborating, that we can create a pull effect together with customers to decrease market barriers. And we have already seen a very good development in the promotion of decarbonized solution, because this will be the future. Good. And I just want to give you an insight into our strategic partnership with Neste. We closed last October. So we focus on sustainability as business opportunity for us as company, and especially for our customers, to support them to reduce GHG emissions, that everybody is able to reach decarbonized targets in our strategic agenda. We want to show and discuss the technology openness to use as many as possible solutions as for decarbonization. We want to correspond to stricter emission regulations, which also affect our customers, which we would fully want to support. And we would like to gain an innovative market differentiation with our partnerships. So these are the main pillars. And if we have a look on the summary perspective, sustainability is increasingly important and a prerequisite to remain qualified for existing business relationships, and to also develop new customers and new markets. And so HVO is already commercially available today. So there's today an option to decarbonize the portfolio. And most of our engines within the power gen are also already released for EN 5914 fuels, and the pricing mechanism in Europe are mostly depending on European and national, especially national regulations. And we want to strengthen with Neste to keep and extend our internal combustion engine customers during the energy transition phase. And now I would like to hand over to Pamela. Thank you.
Excellent. Thank you, Michael and Anna, for setting the scene for us of the HVO market. If I can just remind all of our listeners to please submit your questions to us. Don't forget to submit those while we are presenting the first part of the presentations. That means that we will be more likely to answer your questions and have time for your questions before the end of the 60-minute discussion. If I can now hand over to Anya. Anya has 13 years senior management experience with fluids and lubricants. Since 2019, Anya has been senior expert for fuels, and she's going to be talking through the production process for fossil diesel, FAME and HVO, as well as the composition, behavior and specifications. Anya, over to you.
Okay, thank you, Pam, for your kind introduction and a warm welcome to the audience. I have the pleasure to give you a short overview about the chemical aspects of HVO in comparison to fossil diesel and FAME. Let me start with the production process of fossil diesel. Feedstock is crude oil, which will be heated up to 600 degrees. Depending on the temperature, different products can be separated or distilled during the heating process. At low temperatures, for example, the highly volatile products with a few carbon atoms, like for example propane, are separated. At high temperature, long chain products such as heavy gas oil are separated also. Diesel with an average chain length of about 16 carbon atoms is more separated in the medium temperature range. After distilling off, the molecular structure of the diesel is modified in a second step, and in a third step, sulfur is removed if necessary, and additives or FAME are mixed in. The production process of HVO and FAME, on the other hand, is completely different from that of fossil diesel. Feedstock for both diesel fuels is fat and oil based on waste products. This picture shows you a fat molecule. The fat contains fatty acids, which are linked to an alcohol. The fatty acids can be saturated, which means that they react very slowly with other molecules, but they can also be unsaturated, shown here by a bend in the chain. Unsaturated fatty acids are very reactive molecules which like to react with, for example, oxygen from the environment. In the production of FAME, the fatty acids of the fat are reacted with the methanol to form fatty acid methyl ester. Both the oxygen, shown here in red, and the unsaturated structure of the fatty acids remain in the biodiesel. Glycerol is split off as a byproduct. In the production of HVO, the fatty acids of the fat are hydrogenated with a renewable hydrogen. In this process, both the unsaturated fatty acids and the oxygen are hydrogenated, and this produces pure saturated hydrocarbons and propane. This different chemical composition of the fuels lead to different chemical behavior and therefore to different specifications. Here, the different chemical composition of the individual diesel types is shown in a little more detail. Fossil diesel, like an EN 590, consists of up to 6 different hydrocarbon fractions plus biodiesel. The hydrocarbon fractions show different structures. The structure can be linear, it can be branched, it can be cyclic, and it can be aromatic. The biodiesel can consist of, as we already heard, about saturated and unsaturated esters. Paraffinic diesel, the HVO, on the other hand, consists of only two different hydrocarbon fractions with a linear and branched but saturated structure. Last but not least, the FAME consists of saturated and unsaturated esters to nearly up to 100%. As mentioned before, these different chemical composition will have an influence on the properties of the diesel. This picture nicely illustrates one different property based on the different composition. On the left hand, fossil diesel burns with a clear development of soot, as you can see here. On the right, HVO burns without soot formation. The soot-free combustion is essentially due to the absence of aromatics and naphthenes within the HVO. This table shows the behavior of HVO and FAME in comparison to fossil diesel on the basis of these selected fuel properties. The green arrow means that the corresponding diesel performs better than fossil diesel. The yellow arrow means that the fuel performs equally well as fossil diesel, while the red one indicates that it performs worse. I think the colors speak for themselves. HVO performs better than fossil diesel on almost all parameters. Only the density is lower than that of fossil diesel, which can have an influence on the engine power or the fuel consumption. For FAME, caution is required due to its oxygen content and the unsaturated esters. Based on these ingredients, it ages rapidly, forms deposits, and therefore can cause problems within the injection system and during storage. This is a listing of the major differences between the various diesel specifications. I would like to comment on only a few points. I would like to start with the local applicability of the specification. Paraffinic diesel is specified in Europe in the EN 5940 Class A and Class B. This is necessary since the density of the paraffinic fuel is below the minimum density for fossil diesel according to the EN 590. In the US, on the other hand, paraffinic diesel is specified together with fossil diesel in the ASTM D975. There is no separate spec for paraffinics. This is possible because there is no density limit in the ASTM. The two classes within EN 5940 are necessary in order to specify the different ignition properties of the paraffinic diesel. For Class A, the cetane number is at least 70. For Class B, it is at least 51. RRS has approved both classes with the additional restriction for a maximum ignitionability of about 80 and a limit value for the lubricity of about maximum 400 microns. Otherwise, all the characteristic values of EN 15940 are adopted. These MTU specific limits are also valid for the paraffinic diesel within the ASTM D975. 100% FAME is not released by RRS at the moment. The European spec for diesel was only included for the purpose of completeness. Let me conclude my presentation. In general, we have seen that there is a correlation between feedstock, production process, and chemical composition. The different chemical composition influences the chemical and physical properties of the fuel. In relation to paraffinic diesel, this means in detail that the high proportion of linear and branched hydrocarbons leads to a high ignitionability. The low aromatic contents leads to lower particulate emission and less swelling of elastomers, but also to lower density. The absence of oxygen and unsaturated hydrocarbons leads to better storage stability, and the linear and branched hydrocarbons lead to lower water solubility and consequently to an improved water separation. This will also improve storage stability. This brings me to the end of my presentation, and I give back to Pam.
Anja, thank you for sharing that presentation with us. It was so detailed and really enlightening. So I appreciate you sharing those details with us. And if I can also just remind our audience to share their questions. Thank you to those who have submitted questions. We have many coming in, which is going to make for a lively Q&A discussion later, I am sure. If I can now hand over to Robert. Robert started in mechanical design for Series 2000, and since 2012, he has been in the role of Senior Manager for Global Technical Third Level Support for all power gen engines. Robert, I'm going to welcome you on screen and hand over to you for your presentation.
Yeah, thank you, Pam, and also a warm welcome to the audience, and also thank you to Anja for the detailed insights about the different types of fuels we use. And I think this lays a good path to my presentation, as you can now understand how different fuels can be, although on the first glance they look the same, but when you look in the details, as Anja already explained, they are very, very different. So when we first had the idea to bring up these fuels, it was in 2016. We took the decision far from easy. So, you know, with a new fuel in the market, you are also responsible as an engine manufacturer for the customer satisfaction. And you can imagine that the customer satisfaction is the end, what we are aiming for. So we were first confronted with this fuel in 2016 by a STORE project, a short-time operating reserve project in the United Kingdom, where they wanted to use this fuel both for ecological reasons, but also for the storage capability improvements we had there. This fuel up to then was unknown to us. We heard about this. There were pre-versions of the standard available in the market, but it was hard to find a supplier. And at that time, we decided to work together with Neste Fuel in 2016, get in contact with this fuel and make our first tests with this. The first tests were mainly to simply start an engine, Series 1600 and Series 4000, as Michael Stieper pointed out in the beginning. These are the engines we have now released for these fuels, and simply do a run test with this and check for material compatibility. Then we had a long discussion with the customer. We shared our concerns. Afterwards, we learned that these concerns were not true, but you can think that introducing a new fuel in such an important project for the United Kingdom, you're very cautious. So we were open to the customer. We said we lacked the experience at that time, and he was willing to start with this, and it ran very well. We had no issues, no technical problems at all. So we decided to go to different customers, other customers, and say, okay, we have now a new fuel coming up. We see the potential of this fuel in the market, and we think that this may, for several customers, also be a good idea to switch over to HVO. With the support of Neste and the increasing experience we had with this fuel, we got all in all 55 questions or cases where we got a question for a project-specific release. And with 24 of these projects, we really introduced this fuel in the customer market. So you can say from 2016 on, we gained more and more experience in the field. And also, I'm glad to say, as we expected, but it's always too good to know that the truth is also seen by the customers, we faced no negative experience in the market with these fuels. Coming to my next slide. We always struggle within power gen to get the runtime on the engines. Most of our gensets or engines we have in the field are emergency standby gensets. They do their regular test runs, but they are hardly in a continuous operating mode. So we tried to find out how this fuel behaves not only on short notice, but also in the long term, to see if we have here any kind of long-term effects we simply haven't considered. For example, one of the first tests we had with the marine colleagues with the German Water Protection Police in the city of Hamburg. and they realized the high amount of water coming out from the water separators. But when you have heard the presentation from Anja Keller beforehand, this was caused by the water hydrophobic structure of this fuel. So the water is easily separated. So we had customers complaining that this fuel is less quality because of this amount of water coming out, but we were quite sure, or we confirmed to the customer that it's a good thing that the water is coming out. But you see, there was some uncertainty in the market at the beginning. Everybody was a bit cautious, tried to look into the details about this. And we were in eager need to have a field test with a large amount of runtime. So we partnered up with other applications, in this case with marine, but also we partnered up with rail application, with C&I application, other ones. And for marine application, we found a customer, a ferry in the northern part of Germany, who was willing to perform a long time test. Here we ran more than 9,000 operating hours on this fuel. And we can confirm that also in this test, we have seen no negative effects, and these results from this long-term test were also comparable to our engine. So we can say this knowledge transfer was taking place, and we can say that now that also for our power gen engines, we are very sure that over long-term operation of the engine, we see no negative effects of HVO. So all these customer uncertainties we saw there, we could argument that we have tested this on a similar engine or almost similar engine with a near or same fuel injection system, and we saw absolutely no issues here. So what did we have up to then? We have experience in HVO suitability for the material compatibility together with our chemistry department and the field tests. We could confirm that the engine power output is the same both on our test benches and also with the customers. We took some parts out of the engine, looked into this in detail, make some analysis, and saw that the TBO and maintenance schedule stays the same. In some parts, we even hope that we can lengthen the TBO of some components, as this fuel behaves better with the materials in our engines than EN 590 or other diesel fuels are doing, just as Anja mentioned beforehand. And so we said, okay, we made also some emission testing, and we saw what our partner Neste gave us and as an indication about the emission behavior they expected, that we see a reduction in particles by up to 80% depending on the load point, but also in the nitro oxygens by in average by 8%. What was still open was, as this is only half of the story. So at that moment, we knew that the engine can deal with this fuel. You have the same power output and everything is fine. But the other half of the story is about customer satisfaction. Is the engine still fulfilling each and every detail in the customer needs, like load acceptance, noise emissions, whatever you call it? And so we decided to go into some back-to-back tests, some with customers, some in-house, and test this also. Here you can see, for example, the result of an emission back-to-back test we performed in 2021 on our engine, where again, we confirmed that the soot or the particles were far lower, by up to 80% lower, but also the other volatile compounds were lower with HVO than with, for example, in this example, heating oil, but the same is also true for EN 590 or other fuels. Another back-to-back test we performed was about load acceptance. We also deliver engines in uninterrupted power supply units. We have very strict demands in the United States, about 10% load acceptance limits we have there, according to the NFPA 110, for example. So this was also very, very important for our customers, that load acceptance behavior still stays the same. When you look into these two graphs, you see on the left side, heating oil, red diesel, or EN 590 makes no difference from the behavior here. On the right side, you see HVO, and it's very hard to find any differences at all. We saw some very minor differences, but the difference we saw were lower than the tolerances we had in our test equipment, so we can confidently say it has absolutely no negative effect on load acceptance. We still had a customer doubting this. He wanted to have a proof. So last week, even we performed a back-to-back test in Liège in our company producing uninterrupted power supply units. And also there we could confirm that the load acceptance of the engines still stays the same, just like maximum power output, fuel consumption, noise emissions, and everything else. Okay, to sum this up, what does this mean for you, for the customers? We have an emissions improvement significantly in the area of particles and soot, but also other volatile compounds are reduced with this fuel. The load acceptance, maximum engine power, etc. stays the same. As Anja pointed out beforehand, the storage life increases. So we expect best case, depending on storage conditions and on your fuel supplier, that even a doubling of the time is possible. And when you calculate this in your operating cost and your life cycle cost of the engine, and you consider that this fuel can be stored far longer in your fuel tanks, perhaps this fuel is even cheaper than using EN 590, depending on your situation on site and your fuel supplier. This fuel has also, as mentioned by Anja, a lower density by around 3%. So you have to consider this when in your tank layout. When you have a limited tank size or fuel tank size, please consider this, that the volume of fuel you need is 3% higher, the mass is 3% lower. The hydrophobic characteristics we already mentioned, so we strongly recommend to use a water separator when you use this fuel, but this is something we recommend all the time, also with EN 590. But please don't be surprised when you see more water coming out because of the characteristics of these fuels. Sealings may be affected during switch from fossil fuel to HVO. We saw in the slides from Anja that this fuel has a different swelling behavior. So it's not that these sealings disappear or somewhere or are solved in this fuel, but simply the swelling behavior of these sealings is a bit different. So we also recommend to have a close look on your genset, on your engine in the first time. But again, we don't expect any issues here, any problems within everything and all parts, components of the engine you can buy with us. All the options are HVO proved, that there's no problem. Yeah, same for the genset. So and now I'm looking forward for your questions later, and I'd like to hand over to Pam. Thank you.
Thank you, Robert, for taking us through the impacts of HVO on fuel engines, and also for taking us through the journey, the customer journey and the MTU journey that has been embracing the development of HVO fuels. I'm now going to hand over to Mats. Mats has 24 years experience in engineering, business development, sales and marketing. And Mats is going to be sharing an overview into the feedstock benefits and production volume of Nest My renewable diesel. So Mats, over to you.
Yeah, thank you, Pam, and thanks also to the Rolls-Royce colleagues for the great presentations and the collaboration here. First, maybe just to clarify, we call our product Nest My renewable diesel, and we've been talking about HVO today. So renewable diesel and HVO it's the same thing. It's just, for example, in North America, typically they use the name renewable diesel, and in Europe it's more known as HVO, but it's the same product. So just so we don't have any confusions here. And looking a little bit about Neste and how we came into working with HVO. So we started as a traditional oil refinery company in Finland, but then have transitioned the company into focusing on renewable fuels. And we started producing HVO more than 15 years ago, and it has been a big success. When we started this, people were a bit hesitant. Should we do this? Why do we need a product? But now we see that we're well positioned, and it's good that we started this early and to build up production capacity and knowledge. And we have also added on sustainable aviation fuel. and our latest area is renewable polymer and chemicals. So, and we're now the world's largest producer of HVO and also a leader in the aviation fuel, sustainable aviation fuel side. We also have strong climate commitments within the company, so we have a target to reach carbon neutral production by 2035. And a little bit about the availability then. So our product is available at 600 public filling stations across Europe and North America. But that is the public part of it, and it has been used for a long time in passenger cars, in truck fleets, in buses, and so on. So it's really a proven product in high or big volume fleets. And we're also active in 28 countries. So we also do this type of home-based deliveries with our distributors. So we come and fill up tanks and so on. And we have around 4,000 customers that we have served worldwide. And availability in Europe is getting better and better. I would say we're covering almost all of Europe, and also in US. We started in California, but now covering more area there also, and also growing in Asia Pacific area. So in areas like Singapore, Japan, New Zealand, and Australia, and so on, availability is increasing. And we produce these fuels in Finland, in Rotterdam, and in Singapore. So there we have our refineries. And this year, really exciting, we're also coming online with a joint venture in the US, in California and Martinez. So really increasing the production capacity. So even though we are the biggest one, we're actually investing quite a lot to increase it further. So today we have around 3.3 million tons production. And this year it will grow up to 5.5 million tons with these expansions. And in 2026 we have additional expansions coming online, so we reach 6.8 million tons. So basically more than doubling our production capacity in the coming years. And a key part of the product is the greenhouse gas reduction that you get when using the product. And last year, our product helped our customers to reduce greenhouse gases with 11.1 million tons. Quite a big number, but what does this mean? So we translated into the emissions of passenger cars just as a calculation example. So it means the emissions from 4 million passenger cars that number represents. So quite a big saving there. Coming into then how we produce these fuels. So we use a mix of different waste and residues to make the fuel. So some of the biggest raw materials we use are used cooking oils and also animal fats and waste from the fish industry. And all these raw materials are sustainable produced and traceable to the point of origin. So really keeping track of the whole chain. And this is also a very controlled process in the regulation and how it can be calculated depending on what raw material you use. So coming back to some of the benefits of Neste Meyer renewable diesel, and especially compared to the fossil diesel. So it's made out of 100% renewable raw materials, and it has a really good greenhouse gas emission reduction compared to fossil diesel. So we are reaching between 75 to 95% greenhouse gas reduction. And that is a really competitive value. When you start comparing it to other technical solutions that are out there to reduce greenhouse gas emissions, this is really, I would say, really top of the line values we are achieving. And if you also then add in that you don't have to change your infrastructure, your equipment, and so on, you can easily make this switch. I think that makes the choice even simpler and really an easy switch to make. And to summarize some of the key benefits with Neste MY Renewable Diesel, it has excellent cold weather performance. So our standard product has cold weather performance down to -22. But then in some regions like Sweden, where I'm from, the winter grade actually goes down to -30. So it's even possible to do more than that. It has a high cetane number, which ensures a clean and efficient combustion. And it doesn't require additional maintenance and so on. It's just to go with it. And if you compare it to this traditional biodiesel form where you could blend up to 7%, otherwise you need a dedicated powertrain for it. When you use this HVO renewable diesel, there's no blending limit basically, so you can mix it however you want. So if you happen to have already 50% fossil fuel in your tank and then you fill up with HVO, it's not a problem. It mixes with the fossil diesel because it has the same properties basically. So you can use it in any mixture you want there. But of course, to get the good greenhouse gas reduction, you should use the 100% product. As we heard before here, it has excellent storage properties. We don't have any biodiesel or pharma in our product. It's a 100% HVO product, and there's no oxygen in the product. So these type of problems that could occur in the past with growth in the tank and so on, that is really not an issue here, and it's a very stable product. We actually saved a barrel from our first production batch, and we have it in our technical lab. And every year we go and take samples to see what happened with the product, and it's still going strong. No issues observed or anything, no degeneration. So really a stable product. And from a handling standpoint, you will also notice that it doesn't smell. It's a really clean product. It doesn't have the aromatics. So just from a handling standpoint, it's also a nice product to handle. So that was it from my side. Also looking forward to the questions here and handing back to Pam.
Mats, thank you so much for taking us through what makes My Renewable Diesel competitive and truly valuable. It was fascinating. And I think I'm going to now ask for everybody else to join us on screen again. We have had an unbelievable amount of questions come through, which really does speak to the importance of this topic. And a friendly reminder to all of those listening in that if we don't get to ask your question, we certainly will get back to you after the session has concluded. So welcome back, everybody. Thank you so much for your presentation. I am going to dive straight into the first question, which I'm going to direct to Anja. Even though this has been a mainly European-focused discussion, the question actually concerns Indonesia. The Indonesian government has just announced the use of B35 diesel, which is 35% of biodiesel or HVO, and is targeting B40 in the near future. What is MTU's strategy to address this requirement, as the current MTU diesel engine for PG application is only good to B30 and for standby application only?
Okay, thank you for the very good question. Let me divide the question into two parts. For the engine which are already released for the HVO, there is no problem how high the content of the HVO is within the fuel. You can drop in as much as you want, and the approval is still valid. For biodiesel, for FAME concentration, we have already approvals up to 30% for some series. And at the moment, there is internally a great discussion about how to start testing for the approval of higher contents of biodiesel. So we are internally quite on discussion, and I think in some weeks or months we can answer better to which concentration we want to give an approval in future.
Thank you, Anja. Definitely a space to watch then. Robert, I'm going to go straight into the next question. There's no time to waste. Certain seal materials have been noted by Nest to be potentially impacted by HVO, where the seals can shrink if previously exposed to diesel. For retrofit applications, diesel to HVO, do you see any issues with this in your engines?
Thank you, Pam. So also thank you for this question. We get this question from time to time, and it's more than valid to ask these questions. And to be honest, yes, for some sealings, we saw some issues here. This is why we point out to look at your engine when you shift over from EN 590 or other mineral oil-based fuels to HVO, but simply not because the HVO is attacking the sealings or whatever, but it's too good, to say it this way, because some producers of fuel filters or sealings, they consider that these sealings weighs well when used with EN 590, and with HVO they simply don't do it. So when you switch over, best case is to change also the fuel filters. When you transition over to HVO, then you shouldn't have this issue. We had this discussion with, for example, with Mann und Hummel, the standard fuel filter we use for our engines in the past, and they changed the material now also in their fuel filters, but I wouldn't say it's an issue. You may see some small leakages. It's not like the fuel is pouring out in a wide stream or something. You may see some drops here and there, and simply by changing the fuel filters, you can solve the problem, and with other components, we haven't seen any issues here. Yeah, but you can also see this in our fuels and lubricant specification where we point out to this topic. There you can read it also. Thank you.
Thank you, Robert. I have another question for you, staying with engine-related queries. Is the HVO release on the Series 1600 and Series 4000 engines only for new engines, or also including existing engines? If existing engines are not included, what is your approach for approving HVO use in these applications?
So also thank you. We can point out that the engines listed in our fuels and lubricant specification are also released for this fuel when they are already existing or in the field. So we make no differences here. We had the big chance or the luck that we didn't have to change anything on the engine at all. This the same data set, the same components, the same combustion procedure, everything stays the same. So all engines, series, for example, Series 4000, GO3, GO4, Series 1600, already in the field can simply use HVO as any kind of blend as a pure 100% HVO, so there's no issue. With any other engine like Series 2000 or classic engines we have, please feel free to contact your local point of contact us, contact me. So then we can look into this. As I mentioned during my presentations, we did already in the past some project-specific releases. And when we simply have no experience, it's not that we've seen any negative experience or something. We simply, for some engine types, don't have the experience. Feel free to contact your local dealer, your person of contact, or us. So then we can look into this. And perhaps you're the next customer guiding us or helping us to release this type of fuel for an engine we don't have in our portfolio released for HVO by now. Looking forward for this.
Great answer. Thank you, Robert. My next question I'm going to direct to Anna and Mats. With the expansion of the HVO market, when can we see HVO begin to fully substitute diesel in all markets, on and off highway?
Yeah, it was also a good question, right? As I showed, I mean, we are expanding production here, and as Anna showed, we're now in good companies. More and more of the oil companies are starting to produce HVO also, and I think that will really help with availability. But we're also working closely with our customers to understand where they see the biggest need. So it's input from market and customers also interesting for our strategy when we're expanding into new markets and countries to understand where the demand is high.
Yeah, and may I add? So I think So a fully substitution from HVO is currently limited by the feedstock. So I think it's also heavily investigating on additional amount of feedstocks like algae or lower quality waste. But it's not only a HVO solution. To decarbonize the fleets and on and off highway, I think technology openness is key. And therefore, it will be afterwards along the characteristics of an application. There will be the strongest tendings towards HVO, or is it a battery? So I think it's afterwards a mixed combination to fully replace a fossil fuel.
Yeah, I fully agree. I mean, there's sometimes this wish to find the winner and which solution will solve all. And the unfortunate answer is that not one solution will fix everything. It will be a mix of solutions, and we should use the solutions that make sense in certain applications. Fully agree.
Thank you, Mats. Thank you, Anna. Michael, I saw you nodding there. I'm not sure if you'd like to weigh in on the specific question. We do have several more, so I'm just giving you the opportunity to weigh in if you'd like to.
Just to really emphasize what Mats was saying, there isn't one energy transition and the one holy grail. And I'm deeply convinced that also regarding fuel type HVO, but also regarding the internal combustion engine technology, there will be applications where we will see this awesome technology with the properties for the next decades. And that's a clear differentiation also between on-highway and off-highway applications that I liked a lot about the question, because not everything we can see on highway is one-to-one converted into off-highway applications just due to power density and technology proposition. So therefore, HVO will also have in the next decades really nice opportunities to contribute towards net zero, regardless what is currently in specific markets discussed on highway applications.
Indeed. Michael, thank you for weighing in on that. We do have time for only one more question. So I'm going to ask Anja, what is your view on the gum content of HVO? And is this a concern in MTU engines? Are existing gum content test standards suitable for HVO? And they refer to ASTM D381 and ISO 6246 specifically.
Sorry for this. Thank you for the question, but sorry, I think it's better for Mats to answer the question.
Apologies for that, Anja. Mats, would you like to weigh in for us?
Yeah, I think here we would need to come back to that question separately here. But it's a good question, but I think we can revert back here after the event to that details. Yeah.
Mats, perhaps a wise choice, and it won't be the only question that we come back to after the discussion. I would like to thank all of our panelists, our experts, for joining us today. I feel like we could spend at least another hour talking about the topic. So I do appreciate your time. For sharing these insights with us and our listeners. Thank you to our listeners for joining us as well. It's been a pleasure to have you with us today. On behalf of MTU and Rolls-Royce, as well as Power Engineering International, I'd like to say thank you for today's session and also remind you that the session was recorded and will be available on demand for you to listen to at a later stage. And that will be accessible on the Power Engineering International website. Until next time, I'd like to ask that you take care, keep well, and we look forward to seeing you again. Bye-bye.